Hello folks, welcome to Star Schema Automation for SQL Dedicated Pools. So I'm going to be spending the next hour talking about how to automate the kind of design and loading of your enterprise data warehouse, right? Now this is assuming that you've got your data, ingested into a data lake, say, and extracted into staging tables. So I'm just really focusing on the transform and loading of the Star schema. For those of you who don't know me, my name is Bob Duffy. I've been around the sort of SQL Server and data warehouse industry a long time, about sort of 30 years maybe, right? I'm a certified architect, a certified master in MVP, a fast track recognized architect, and analysis service maestro. And I used to work at Microsoft over 14 years ago as a senior data platform consultant, where I was the subject matter expert for data warehousing and business intelligence. But nowadays, I just work as a data architect at a Microsoft partner in Ireland, and strangely enough, I build enterprise data warehouses, which is really where this talk comes from. That's kind of my experience in how we build large-scale data warehouses for our customers. So I'm first of all going to be just talking about some EDW and ETL design principles and what an automation framework kind of looks like. Some modeling fundamentals, like, most people should understand what a dimensional model and a bus matrix is, but just so we're all on the same page. And then let's actually try and build and populate one as part of a demo, right? So starting off, data warehouse and ETL architecture, right? So this is what I call universal architecture, right? It could be modeled regardless of your technology stack. How do you build a star schema? So on the right hand side is our goal. We want a star schema, right? On the left hand side of the day we've got a bunch of source data, be that CSV, spreadsheet, Parquet files, JSON, XML, line of business, set systems, whatever, right? So the first phase, as far as we're concerned, is always to extract that into staging. Okay. Now there's a dotted line here, meaning it could be virtual, where it's not physically moving into staging, because you could be moving something like Polybase that it doesn't actually create a physical table, but the process of extract is still there, even if the physical stage isn't. Then we're going to transform it from the raw source data into the cleansed and modeled star schema, which is what we're really focusing on in this talk. So that's really, for me, that's the complex part. That's where I want my senior consultants working on. The rest of it is fairly straightforward. And then loading is just taking that transformed kind of data and making sure that it's populated and loaded in the correct way without loading duplicate records or anything like that into the star schema. Now, that kind of transform kind of magic is really, some people call that cleanse, conform, curation, integration, or whatever you want to call it. And there's a number of different ways of doing that, right? So we're going to be focusing on the SQL-centric way, which is where everything is done inside a SQL DB engine, or the kind of SQL language. Some people call that ELT, but it's still got those three phases of extract, kind of transform, and load. If you think about it, like bringing it into staging, transforming it, and then loading it. Some people use ETL tools like what used to be SSIS, or perhaps data flows in ADF or something like that. Doesn't seem too popular nowadays. I think SQL-centric is one of the more popular ways I see, or compute-centric. So you're using something like Databricks, Spark, or something else, and you're not really using a database engine at all, but you're going to be using the kind of data lake as your staging area and as your final star schema area. Regardless of what tech stack you're using, the process is the same: extract, transform, and load. Okay, so we're going to be covering a SQL-centric. So we won't be covering Spark or Databricks or anything like that. It's just all going to be inside a dedicated pool. So as soon as we get our data extracted into the SQL pool, we don't need any other tools in order to automate it. We have everything that we more or less need, right? So as an example, I'm going to take AdventureWorks and we're going to actually build a star schema. Now, not the AdventureWorks that most of you are probably used to. So most of you have probably seen AdventureWorks demos where they're looking at internet sales and reseller sales. In this one, I'm actually taking the ERP aspect of AdventureWorks, which is where there's a chart of accounts and a financial system that's actually built into it. So there's 7 or 8 source tables that we need to build, and in this case we got some of them in Excel and some of them in CSVs. Some are full load and some it's only giving us incremental files every day, right? So this is what we're going to try and load, right? Now, before I show you it loading, the mechanism that we're going to use is a framework, right? So what this means is we're not really going to be coding from first principle. The way a framework works is you have reusable components that have been written before that are standardized and parameters, right? That and parameterized that do standard pieces of work, right? We call them either piping, where it's just really copying sort of data around, or a deterministic transform. So say, for example, you're loading from one table into another table rows that don't exist in that, right? You don't need to hand write that T-SQL. There's lots of ways of generating that kind of T-SQL for you. So what you want to do is package that up in a library, and then a worker will call that library, and a controller will queue that work with some orchestration to say what happens when. And a framework might have some features like login, lineage, error handling, and at the end of the day, everything's going to be controlled by metadata. So when you're working with an automation engine or a framework, most of your development work is just really registering metadata, or you might have some custom business logic, which I call meat, right? And that's like work where you're writing a transform, but it's specific, it's not reusable, you know. So that's where we tend to spend most of our work, right? Now, there's a blog article that I've written that goes into a little bit more detail, but most of our automation frameworks use this type of architecture. And it's a book that I'll show you at the end of the day that goes through some of the concepts of frameworks. Dimensional modeling, right? So hopefully most people know what a star schema is, but there's some authoritative books on that, right? Obviously, the Kimball is the most famous book, the sort of data warehouse toolkit. Theory hasn't really changed that much in, like, you know, almost 30 years. You still have dimension, facts, bridge tables, SCD2, degenerate attributes. You know, these are all terminologies that anyone who's used to building data warehouses knows what they mean. One of the complaints about the Kimball theory is it kind of describes what a dimensional model was, but it didn't really describe, you know, how you design one or how to load it, right? So how to design it, there's a great course that's shout out to Lawrence Core on Agile Data Warehouse Design, where it actually talks about how to design and approach building a star schema for a large project from a data modeling perspective. And what we're then talking about is, once you've done that work, how do you implement it without writing sort of bucket loads of bespoke code, right, to get to your end goal of your star schema. So the first thing that you're going to need is your bus matrix, right? So hopefully most of you are familiar with this on screen. It's the effectively, you've got your dimensions and your facts are your kind of measure groups, right? And usually this sort of data modeling is done in, say, Excel. So on screen is the Excel version, and this is exactly how we do it on commercial projects, right? So we have an L1 bus matrix that we do at the very start of the project that just really understands the subject areas, right? So how many verticals are we dealing with? Sales, finance, manufacturing, procurement, supply chain, and so forth, right? And then what are the business processes or business objects that relate to those kind of subject areas, you know, customers, suppliers, products, and so forth, right? And then as we get down to more detail, we start putting the detail for all of the objects, starting with just the keys and then the attributes on those. So this is an L3, so it's the finish. So if I go to any of the objects, hopefully I'm going to see the definition of what the field is called, its data type, example values, any special ETL rules, where it's mapped to in the source system, everything that gives the ETL designer enough information to map it. Notice a lot of the columns are blank here, which is fairly typical for the way that we work, because often the mappings are intuitive, or the designer will say to the developer, oh, you go away and figure out it, here's a CSV and here's a spec, right? We won't necessarily spoon feed every single piece of design information, because that takes a long time, but we would certainly store what we want to call the fields in the data warehouse, what sort of data type, what is the nullability if they have a default value, and so forth, right? So by making use of the hyperlinks, this is quite nice. And then a fact table and measure group, straight out of Kimball theory, is going to have a keys and measures. So in this case, only one kind of measure because it's a child of accounts. Don't ask me why department group key is a big int. You talk a bit of small int, right? That's probably a bug there, right? So that's your bus matrix, right? So we would generally spend a week or two on a project, or could be a couple of weeks if it's a really big project, building this bus matrix and understanding the kind of business and what the end star schema is going to look like. An important thing to note is that there's two ways of building this. There's what we call bottom up, which is where you're going to get hold of your source data and say, well, how would we model this kind of source data? And top down, where you're going to look at your reports and your business analysts and your business users and what kind of data they need and design it from that point of view. There's also, as outlined in Lawrence Core's box, the business design point of view, right? Where you're going to use techniques to, for each kind of measure group, check that it's got all of the things that it should have. I think it calls the 5 W's is a common theme, you know, what, where, who, how, why, right? Anyway, once you've got that, on a large system, you're not going to be able to build that all at once, right? In the old days, people tried to design the whole of the data warehouse up front and then build it all in one go. It was too big on large kind of systems. So what we want to do is just take a narrow slice and just complete the design and implement one of those areas. So after we've gone from the subject area to the business process to the field level data, we might make this a prioritization matrix where we look at all the business processes or the subject areas and decide which one has the highest feasibility with the highest business impact. Usually accounts and sales are going to be very, very high up there, right? Okay, so that's how we start. Now, once we've decided to build it, then that's what the rest of this session is on, right? So I've got my VentureWorks. I'm assuming that I've completed the extract phase, right? So I've used ADF pipelines. Hopefully I've had some sort of metadata automation or some way to bring all my files into my staging area, right? So my starting point is I've got a SqlPool. I'll just bring up the screen here, right? Which looks like this. And you'll see I've got these tables. I've got a schema called STG. I've got 1, 2, 3. I've brought in 7 files that are going to be used that I now have to transform and load to create my star schema. So I'm going to switch over to Azure Data Studio and we're going to show a demo of how to do that. When I run this query, I'm just going to check that all of my staging tables have been loaded. There we go. Yes, I've got rows in all my staging table. I've got transaction table. No, it's not high volume. It's only got 39,000 rows, right? It's not a lot. But let's now create a star schema. So the first thing I do is create my first dimension, right? Which is, I'll start from my currency dimension. We'll probably use start for date, right? But let's start with that. So what I've done is I've built a metadata system because I want to soft code this bus matrix, right? So for every entity in here, be that dimension of fact, I'm going to create a row in a metadata table that describes it, and I'm going to call that EDW tables, right? And then I'm going to model the relationships between them. So effectively, any one table can be related to any other table, because you can have a fact that's related to a dimension. A dimension could be related to another dimension if it was a snowflake, right? So very basic relationships. And I'm going to group them into logical groups for orchestration, like I want to load this set of dimensions or load this set of facts, right? So that's our starter schema as such, right? Let's start with a basic insert, right? So the very first thing I'm going to do is for every object, I'm going to have to create a transform, right? Because I've got to transform it from the source into the destination, right? And the de facto standard that we use is views, right? So now this is the most basic form of a convert because it's got the same fields, there's no joins, but you can see I might be renaming the fields because the source could come in an encoded format, but it comes from an Oracle system, it's all caps encoded, and the semantic model should be expressed in the business language, right? And then I'm going to describe the data typing and nullability and so forth, and I've got an extra key here that comes from the source that tracks the lineage that would have a row in a table that describes the file that was imported. So when I create that view, this is the most basic of transforms, right? So I've written my transform, and I've then got to load it into the dimensional model, right? So to do that load part, what I do is I register in the metadata this one row saying here is my view, okay, this is the table I want to create. So in my physical data warehouse, I want to create this kind of table, right? This is what the business key is, i.e. the unique key, but I want you, in this case, I'm actually specifying that I want to create a primary key, and I'm going to add an identity flag, right? So using dynamic SQL then, we would have written a stored procedure that we can call, so in this case, USP table load, that takes that view and generates the T-SQL to create the table, to insert it into the table, and create the index automatically. So there's no need for a developer to write this sort of repetitive code anymore. Indeed, it would be dangerous for a developer to be writing that code, because with tens of thousands of objects, developers are going to start to do it in different ways, or what can happen is you can change your mind as to how you want it to load, right? As an example, we might have an insert and an update, and then the folks at Microsoft now add support for the merge statement. So we want to change 1,000 dimensions to now be loaded by using the merge. Obviously, if we'd handwritten all the code, that would be very, very expensive. Because it's generated via dynamic SQL, it's not a problem at all. So I'm going to run this, just tell it to connect to that. And first of all, if it is there, I'm just going to drop it first, right? So there's no table. So one thing to notice is we no longer have any physical modeling, right? So there's no longer any physical typing of create table statements within our data warehouse. That all happens automatically, right? If the table isn't there, it will automatically create it. It'll put the identity column on, it'll know all the data types and stuff. It'll add a primary key based on what it was told in the kind of metadata. Obviously, because this is a SqlPool, it can't enforce the primary key, but we have versions of this kind of running on the normal SQL Server engine, and then obviously it would enforce it. And we can specify the table structure and distribution. In this case, because it's a dimension, it's going to default to replicate, but we could override that if we went back to the metadata to say, hey, I want this to use with the distribution, here somewhere. Oh my God, I've lost it. Here we go. Distribution table structure null, right? So we try and use smart defaults so that if there's a null in the metadata, the generating a template will sort of guess, right? And then we insert, and then we create the appropriate index on the business key in case it's got a join on that, right? Now, notice if we run this a second time, the exact same thing, it will regenerate them, but this time the table's already created. So it's only got to insert into, but it's got to obviously appreciate that the data that it needs to insert might already be there, right? So in this case, when I run that, it'll generate this type of template here and it will execute that. So that way it'll only load the 2 or 3 new values that go in there, right? Now this is robust from a point of view if someone comes to the data warehouse and drops the dimension, the next time it runs it will auto create it, right? In some of our implementations we also support automatic schema drift, right? So what that means is if someone goes to the view and adds an extra column, it will automatically add that column onto the physical table with a with effectively an auto table add column or whatever, right? Or with a SqlPool, we can implement change by inserting the whole lot into a new table and then sort of doing a switch to switch them around, right? So with this sort of dynamic way of loading, we can also handle schema drift as well, which means we don't really have to worry about DevOps deployments of the physical schema anymore, because all we've got to worry about is deployment of the views and deployment of the metadata, and then the kind of data warehouse will generate its own schema effectively. Okay, so that's a basic load. One of the most common questions that we get asked is, hey, how did you generate that create table statement, right? Well, the way that we do dynamic creation of those is by using the views, right? If you think about it, SQL Server has obviously a lot of DMVs where it tracks the metadata. So within sys.columns, for every view, I can find all the column names, what the column types, are they nullable, and so forth, right? So what I can do is I can write a stored proc. So here we've got a stored proc, which gives us the columns that would be needed to create that table. So it wouldn't be very hard. I could copy and paste that into a create table, or I could do a create table as if it was a CTAS, right? Or whatever I wanted to do, I could use that to create the table, and that all comes from the DMVs like sys.columns. So to show you this, if you go into here, USP table, what was it? Table create columns. Here we go. Yeah, so we can see here, look, this is joining the sys.columns onto the sys.types to find that, and then it's just reverse engineering that back into the T-SQL that would create that kind of table. So I think a lot of people have sort of published how to sort of do that, but that's an example of that in action. Now let's look at a slightly more complex example. So a dimension upsert. Okay, so what we've got here is I've created a transform now for the account dimension. Now this is parent child, so there's some joins involved. There's a self join in on the source kind of table. It's got a few more columns, but this time we're going to get updates, right? And to help with the updates, I create a row checksum, which kind of gives me a checksum, or you can use a binary checksum across the columns that are changing. Now I've been lazy here and used a star. We generally would have to say what columns are changing, because not all columns would be changing. Some of them are sort of key columns, and some of them don't really care if they change, right? So once we've written that transform view, we can then automatically create and load that table into the dimensional model. Now this time I'm going to switch over to do it in Management Studio because it gives a slightly better output, right? So let's make sure the object isn't created, and then I'm going to call the table load. As you can see, it has generated the create table dynamically by using the metadata in the view. Because of the metadata, it knows what it's got to include, and it's automatically done the insert into that, and it's created an index. Notice it's included the row checksum automatically as part of the business key, so that if we're looking for change detection, we can now do that by using an index, right? That's probably more applicable when you're not using a SqlPool, because indexes don't work so well on SqlPools because of the split across the 60 distributions, right? But let's run this a second time now, and we should get an insert and an update. So I'm going to select that same one, run it again. Now when we run it, you can see that I've got the insert into, and then where not exists, and it's checking the business keys. And when I update, I'm looking for rows to update based on where the business key is the same and the checksum is different. But notice which rows to be updated is all dynamically generated, so there's no need for any of our data warehouse developers to actually write that code. That's very deterministic, right? So that's going to be done by dynamic SQL. Okay, now that's an upsert, effectively insert and update, but there are other patterns to load. More recently, just come out of beta, SqlPool now has kind of support for the merge statement, although there are a couple of, not sure I call them bugs, but kind of limitations in that you can't update certain columns if they're participating in a hash scheme. But we have actually upgraded some of our newer systems to switch from insert and update into the merge. And this is really one of the beauty of a metadata system, is when we change the way the code is generated, we could be loading 1,000 dimensions and they all change their code at the same time. So extensibility and refactoring become quite easy when you're using a metadata system. Now let's look at some of the metadata that we've stored on that, right? So here's the metadata, and when I look at the metadata, I can see that there's some optional flags that I can set that the stored procedure that generates the dynamic SQL can then change the behavior, such as auto drop, auto truncate, false generating a CTAS, or support deletions. So if I set any of these to 1, it'll change the pattern of the load. Now, before we move on, let's take a look at some other features that you're going to need to load your data warehouse, right? If I just flip back to the automation architecture here, right? So enterprise features, right? Every data warehouse is probably going to need login, lineage, and error handling, right? Login, as you load and extract information, you're going to have to log like when it started, when it finished, maybe how many rows. Did it have an error, right? Lineage, so that every row in every table, you're going to want to track back what file did that come from, who did it, or what source system, what date was it loaded, and stuff like that. So we call that lineage. Not to be confused with schema lineage that you get from Purview and modern sort of products. That I'm talking data lineage, like every row of every data in every fact table, like where did that knowledge come from. And then error handling, so if there was an error generated when it loaded, where can we see those errors, right? So to implement that, we want that, I call that fat, right? And what I mean by that is I don't want developers to be ever writing that. So we put that as part of the framework. So when they're writing their transform views, that just automatically happens. And a developer doesn't have to write a single line of code to implement sort of login or anything like that. So the warning sign that your framework's not very mature is when your developers are spending a lot of their time writing error handling, lineage, and login, right? Hopefully that should be taken care of. So let's actually see some examples of that, right? So on my upsert, if I query these fixed tables, I've got a load log, I've also got an extract log, and I query that, and for every time a load is done, before it does that, it's going to log the start date, the start time, a status, in progress, complete, errored, any errors, and the performance information, and where did it come from, where did it go to, and so forth. Okay, and then all the rows of the data. So if I query my dimension, I'll see I've got this lineage key now that I can use to trace that back to the source file on, right? So every row in every dimension in every fact table has that. As a result, we don't tend to have rows like, last updated by last updated date, because you can have a lot of columns added to your fact table. We just have a single column which then maps back to another table that stores that rich lineage information. Okay, so that's how we handle login, lineage, and obviously any errors would then just get dumped into the table so that you can put your operational reporting and stuff like that on top of it. Before we move on to the loading of the facts, that are slightly more complex, I'm going to look at orchestration, because we've only loaded 2 dimensions and we've kind of manually done that, right? In a proper ETL, you're obviously going to want to schedule them to run to load bunches of dimensions, and there could be a sequence or there could be dependencies on that. So typically we call that orchestration, right? Now on screen, if I just go to here, here's an example of how I see customers, and this which comes from actually a Microsoft example of an orchestration. This is what I call manual orchestration. Every entity within the data warehouse is a pipeline, and you can sequence those to say, well, when all these are done, move on to do that, right? So that's great for getting started, but on the scale of systems that we work on, this would be a very bad idea, because you're always constantly changing your orchestration to add extra dimensions, to add extra fact tables, and you do not want to have to come back to manually update these sort of graphical workflows. So we want dynamic orchestration, so when we register the kind of metadata, the correct sequence of events just happens, right, without any need to write any of these low code GUIs or drag things or put in any dependencies. So the way that we do that is when we define the attributes for a particular table in the bus matrix, we give it a load group, and we say, right, first of all, I'm going to load all of the load group 0, and then the 1s, and then the 2s, for example. So if you look at this example, 1, 2, 3, 4, 5 of the dimensions can all be done in parallel because they don't have any dependencies. There is a dimension that is a snowflake because this one depends on some of the other dimensions, right? And then the fact table is obviously linked into all of the dimensions. So you can't load a fact in a star schema generally until you've loaded the dimensions that are required for that. So the load group handles that. And then what we then have is package groups that define a unit of work and what tables are part of that unit of work. So in this case, if I run this query, I say, well, how many package groups have I got? I've got AdventureWorks, one that will load all the dimensions and one that will just load all of the transactions. Now, this is where on a large project, we would split this by subject area, right? So for example, with a large ERP that would have package groups for finance AP, finance AR, supply chain, quality, front office, manufacturing, and so forth, and there'd be maybe 20 package groups, so that different parts of the data warehouse can be loaded in a logical group. And then there would be another table that then defines for every package group what objects within the bus matrix are part of that, right? So for example, for DIM finance, just load the first 6 dimensions, okay? So once we've called that, we then need to have a controller that queues that work and then executes it by calling the stored procedure that we've been calling manually. It can now do that automatically, right? So to show you a demo of that, I'm going to switch over to Azure Data Factory, right? So here's a data factory, and we have a load controller. And what the controller is going to do is it's going to do the logging, right? Then it's going to run a stored procedure to get a queue of all of the work to be done, and then a for loop to loop through every logical group of objects, calling the worker. And the worker then gets the actual tables and loops through these, right? And being ADF, it can do this in parallel, right? So if you've got 20 dimensions, depending on the degree of parallelism that has been set, I think it defaults to 8 generally in ADF, right? You can do all those in parallel. So when we run the load controller, we can now do a group of objects, but with dynamic orchestration. It's going to decide what packages are done in what sequences. Notice that we don't bother specifying dependencies. So we don't say that before you can load this object, you have to load this object. We just give every object a logical load group. And if something has a dependency on a previous one, it goes in a later load group, right? So it's a simpler way of organizing things without having to have specific dependencies. So let's run this, right? Now I'm going to run this from a trigger, perhaps, right? So that I can get the parallelism working. So hold on, let's just check I've actually published it first. Yeah, I haven't made any changes. So I'm going to add a trigger now, and I'm just going to load all of the dimensions at once. So it's 7 or 8 dimensions. So I click run, and let's view the pipeline run. Now, Data Factory has a lot of queue time while it moves through this, but let's look at this running. So the first thing is it's going to log the activity. There you go. Then for every group, it's going to call the worker package to decide which tables to include in that group. That's working away. Now that's finished, and if I go to the load worker, I could go into the instrumentation for the load worker, and I could see that in the load objects, it got a queue of all the tables to do. And just to show that working, if I bring up SQL Management Studio, refresh my table list, I can now see I've got all of my dimensions are created. So I've got dim account, dim currency, dim date, dim, and so forth. So there's my dim date. Let's just check it's got some data in there. There we go. So that's all now been loaded. And if I want to look at the instrumentation, I can look at the load log to see. I have to order that. Order by start date time descending. There you go. So here's what we've just loaded here. Probably from here to here is our particular run there. I think that's a previous failed one there, right? So that one there. Okay, so that's an example of orchestration. Now, one thing to bear in mind is I showed you a worker controller design pattern running in ADF here, right? So I just go back to my pipelines. Here's my load controller and my load worker, right? Because this is all SQL centric, right? We're really generating dynamic SQL. You don't need ADF to be your load controller. You could do everything from the kind of SqlPool. So if you just look at this design pattern, log to start, queue the work, have a while loop, we could write a stored procedure that does exactly that same. So here I should have a load controller. If I could find it. Load controller. Here we go. Let's look at the T-SQL code. So I can call the load controller, and I can also pass the name of a package group. And you could see that what it's going to do is it should be calling a stored procedure to do the logging. Where's that? Yeah, here we go. Execution start. Then it's going to queue the work. So there's effectively a temporary table has a queue of the work, and then a while loop to loop through it. Now, obviously, the stored procedure isn't going to be multi-threaded, so it's not going to do them in parallel, but being T-SQL, it's not going to have the queue time of ADF. So actually, for development and test purposes, if your dimensions are quite small, it's actually much faster to do it just purely via the SqlPool. Don't even touch ADF, right? So just to show you this as an example, I'm working away, and I want to go load. I go... call the load controller and pass it the name of the package group that I want to load, dim finance, and that's now going to load all of my dimensions from my staging area to populate them in my star schema, taking care of inserts, updates, merges, deletes, and so forth. Now it's running, and let's have a look at the T-SQL that it generated. Now, just for debug purposes, it's going to spit out the T-SQL that the framework actually generated. Here we go, that's actually finished now. And you can see that when I called this, it just called the kind of table load procedure for every table, one at a time on the while loop in the correct kind of sequence in order to do the load group kind of 0 first, then load group 1, and so forth. And it's now written all the T-SQL to load my data warehouse, right? So you can switch between using the T-SQL load controller or an ADF load controller, and actually we've written load controllers in SSIS, Azure Functions, like, you know, any ETL tool that can queue data and launch workers can be used as a load controller. But the two that we predominantly use in Azure are T-SQL and ADF. Now let's take a look at facts, right? This is where it starts to get interesting, right? So fact loads. Now facts are slightly different, have to be handled differently than dimensions when loading a data warehouse, right? Because if we come back to our bus matrix, we see that facts generally have much higher volume, obviously, right? But they have to be related to the dimensions. So that relationship has to be stored, and dimensions may have a surrogate key as well, right? So you're going to have to surrogate, and there's other complexities when loading fact tables, right? Certainly physical structure is going to be different. I mean, generally we put most of our fact tables on a clustered column store. I know that if they don't have 60 million rows in them, they're not going to have perfectly optimized segments and row groups, but you know, generally we find that queries run faster on facts in a column store. So with those differences, let's see what we can do. Now the transform can be designed in exactly the same way, right? We're going to put a view and that's going to do the transform. Okay, now I'll switch to do this in SQL Management Studio because it gives slightly better output because it renders carriage returns. There's a feature in Azure Data Studio where it doesn't actually do that, right? So here we have. So I'm just going to naively call table load. I've just made a view and I've done nothing else, right? So let's call that and see what happens. And then after that, I'm going to select the top 10 rows, right? Go. There we go. So this has loaded my fact table now, but the problem is I've got my measures, I've got my lineage key, I've got my my kind of dates here, but I've only got the business keys for all the dimensions, and some of them could be compound business keys. Some of these are quite wide, and I might want these to be surrogate keys, right? So it hasn't related the facts to the dimensions using the appropriate key. So to do that automatically, right, via automation, what we do is we extend the model by storing a many-to-many table that says which tables are joined to what other tables, right? So my finance should be joined to date, scenario, organization, department, account, and so forth. So I can do that by inserting into this EDW table joins. So this kind of models the joins. I can say table 7 is joined to 1, 3, 4, 5, and 6, right? Then once I've done that, I can drop my table, and when I reload it, now my stored procedure that generates the dynamic SQL can generate the correct joins to do the surrogation for me. So I get a slightly more complicated T-SQL that any of you loading data warehouses have probably seen similar statements actually generated. But the key thing is it's not written by a developer, right? The developer only declares what the joins are, and then the T-SQL is automatically generated. So let's run this. Here we go. So now that same data has been generated, but this time you'll see I've now got the surrogate keys. Okay, so this is a surrogate key. It's AdventureWorks is really old. It's using a smart integer, right, for its key, so kind of like a surrogate key. But we just use a date value. Nowadays, I've got a much narrower fact table, and if we look at the T-SQL that was generated, effectively I've joined to each of the dimension tables, and it's automatically replaced the business key with the surrogate key, so that, and notice it's defaulted to a clustered column store index, and it's defaulted to round robin distribution. Now I could change these default behaviors by just updating the EDW tables and declaratively specifying a table distribution or a table structure. But in this case, I'm just going to leave it at the default values, and we've now got a fact table loaded. So if I wanted to, I could now trigger this to load every day, and as my dimensions and my facts come in, they're going to get automatically loaded into the data warehouse. Notice if I run this a second time, then based on the settings, I can decide if my fact table is going to be append only or support updates, or any variation on that that's supported by the metadata. So let's see what it generates when I just call it a second time. So I called it a second time, and this is doing inserts only because it's saying where not exists. But I could have a fact table that did support updates, right, or something like that, right? Now, just to show you an end-to-end demo, I'm going to go back to my data warehouse here. Let's just see, I've got my facts and my dimensions. So see here, I've got my fact finance and all my dimensions. I'm going to select them, here. So was it sorry, it's all in the DBO schema. So all these objects, I'm going to delete all my objects from my data warehouse, and when I run my load controller, I can run that, and this time I can say specify a package group of all, or I could say load transactions and my finance dimensions, but I'm just going to go all. Reload everything. It's going to recreate all of my dimensions, all of my facts, all the relationships between them. It's going to do the update or the insert logic or the truncate and load, whatever design pattern it needs to get that to load. Bang. Let's go that, and hopefully when this runs, it starts running away, my data warehouse tables should all be recreated, reloaded, and everything else. That's great, so that's finished. So we can see that there were a bunch of load workers, probably because we had to load them in 3 different groups to get the sequences correctly. And when we go back to data warehouse, we should see we don't have any objects in the DBO schema. We now have all our dimensions and our fact tables recreated, reloaded, and we could run that a second time to do the Delta management. So that's that working end to end. Okay, now that's end-to-end demo, but let's look at, before we move on to Q&A, I'll go through some of the common questions that we get, right? So hold on a minute. Let's go back to the, yeah. So common questions. What sort of stuff do we typically do in the when we write the views? Because I was only showing like casting, confirmation, joining tables and stuff like that. So typically, yeah, a view would be quite complex, because sometimes it'd be 1,000 lines of code, and it might have these types of common things that we have to deal with. Okay, and then the load. So once we've created that view, this is the stuff that happens automatically by the dynamic generation, right? So any delta upsert logic, deduplication, change detection, surrogate keying, schema drift handling, the actual creation of the physical model, login and lineage, and we have some performance features, which is whether we pre-stage. Do we go direct from the view, direct into the object, or do we put it into a temporary table first so that any complexities in that view are hardened, right? So that's what we do in the transform and the view. Other common questions that come up is, what if I've got a transform that's so complex that it cannot be done in a view, which certainly does happen. In that case, we do use a custom stored procedure, and when you define the metadata, you can put the source of an object as a stored procedure, right? Especially if it's a multi-step, very complex process to be loaded that can't be put into a view. So that's how we handled that. How do we handle stuff like validation? So before I load, I want to validate it, or before I load my fact, I want to infer. So I've got earlier item facts, I want to infer any missing objects into the dimensions. Or after I load my fact, I want to also load an aggregate, right? Now, you could just put the aggregate as a separate step, or what we allow you to do, and I'll just show you this in the metadata, is if I start from config.edw tables, as I said, these are all views. I could put a stored proc, and then the source objects would be a stored procedure. So you could have more complex logic, but we wouldn't be able to automatically create the schema, right? So you'd lose some features if you didn't use a view, but you'd have more control. Something that we commonly use is this, preload SQL and postload SQL. So we might put the name of a stored procedure or just some inline T-SQL to run before we load the object, or something to load after we load the object, right? So that's how we handle those complexities, right? So coming back to the deck there. Here's some useful links. If you want to get hold of the sample code and everything else that we've used, that is actually available up on a Git project in DevOps. It's a public one, so if you click on the link, which I'll try and post in the chat if I can. I've written a couple of blogs on some of the aspects of data warehouse automation. So if you want to read more, just Google Pro Data blog or sort of Bob Duffy blog, and it should hopefully take you to those blogs there. Very interesting book that I've written. Shout out to Andy Lemard and Kent Bradshaw. I'm not the only person in the world who writes automation frameworks, and they've been writing automation frameworks for SSIS and more recently as a Data Factory. A lot of the concepts would be fairly similar to what I've discussed. So if you want to actually read a published book on this approach, that's a good starting point. Special thanks to obviously the Data Platform Geeks and all the sponsors who helped organize this. It's a very big event to organize, and we're very grateful to them for their work. Okay, so I'll wait around for any questions. I'm quite happily answer those, and if we run out of time, I'm on Twitter as well.